Hi.
It's good
How's
to
it
see
going?
you.
Good, thanks.
We have to go all the way to Detroit at Rapid 2022 to see you, even though we live not far apart in Ohio.
Yeah.
So I'm really excited to talk to you today about your new venture, which is called Skuld.
Right.
Skuld. Thank you for correcting my pronunciation. So I know you've been in and around the additive manufacturing area for a while and have love your posts on LinkedIn. So I'm very excited to hear more about your vision for Skuld and how you got started. So how did you get started in Skuld?
Yeah, that's a good question. So, my background is as a metallurgical engineer, and I, out of school, went into kind of typical things, which is foundries and steel mills and heat treating.
That's not typical.
Well, it is for
Okay.
metallurgists, maybe not for most people.
Right,
but,
right.
One of the industries I'd worked in was something called lost foam casting, which is a greener, faster type of investment casting. And several years ago, we had this idea that we could merge 3D printing with this lost foam casting type of process because it's actually like the greenest type of foundry process. It uses about 35% less energy than conventional casting.
That's exciting. So what do you have a name for this new process?
Yeah, so the name of our new process is Additive Manufacturing Evaporative Casting, or AMEC. We just call it AMEC because that's too long to pronounce.
Engineers should never name things, Sarah.
Well, I originally actually named it Transitive Manufacturing, which is a math joke, and no one got that at all.
That's even more nerdy than I thought you could go. So, okay, keep going. Tell me more about this.
Yeah, so there's something already called lost print, or which is based on lost wax investment casting. And that process, you actually have a very thick coating and you burn out the print. But in our process, the molten metal actually vaporizes the print during casting, which makes it considerably faster. But that's why we call it evaporative, because you're evaporating the print during the casting process.
So that's really fascinating. And you've tried this on a number of occasions. And do you have a sense for the size?
Yeah, so we've done proof of concept in a wide variety of metals. As far as size, so the thinnest part we've done was we did a part for the Air Force's Advanced Manufacturing Olympics in 2020, and they actually had us go attempt to do 0.5 millimeter thick walls,
Okay.
so 20 thousandths. That was definitely pushing the lower bounds of the process. We don't know the upside, but we've done up to 26-inch part.
That's pretty cool. So what you're seeing is that there's a lot of opportunities for research and development in this area for this kind of process as Skuld advances.
Yeah, we definitely see a pretty wide range of applications. You know, if you're talking like copper, maybe for things like, wave guides and things like that,
Okay.
stainless steel, like all kinds of things are made out of stainless, from biomedical to nuclear parts. So a pretty broad range of applications I think are possible.
Well, that's exciting. And you have a sense for any of the tolerances? We talked about tolerances previously.
Yeah, so we're still trying to determine the tolerance to separate the print part from the casting part of this process, but regular lost foam can do as good as 0.2%, so it's pretty much the same as regular investment casting. So we expect pretty similar for this process.
Well, that's cool. And you said that you really feel, what are the big points about this process that you feel just captures it?
So I think the main thing is that, one, it's much faster and more affordable than existing casting or direct metal additive processes. It also it eliminates the tooling if you're coming at this from a traditional manufacturing approach, which is the original pain point we were trying to solve. And then I guess the other thing that, now that I've been in additive a long time, the whole qualification problem, the materials coming out of this are cast metal that's very well established materials.
You and I have talked offline about the need to modernize foundries, and do you view that the Skuld approach is an effort to modernize foundries?
Yeah, I definitely think there's a lot of foundries they're very resistant to change because they're kind of the ones that are existing. They're the survivors of the industry. Foundries, like in the 50s, were like 10 times more foundries than there are now, so they are risk averse
That's
because
right.
so many of them have closed. So this is definitely a way that try to, I think, protect that industry and expand it again, re-onshore things, because, if you don't need tooling, it's much more affordable to build a foundry.
What would you say Skuld's mission is?
Yeah, so I'd say our mission is to make metal processes in general more sustainable, as well as more affordable at any volume.
That's an amazing mission. Greener, affordable, sustainable.
Yeah,
Like
I guess I put it in 3 words.
From a business perspective, sustainable.
Yes. Well, I meant from an environmental
both
point. Yes.
Well, Sarah, I am so excited to see what you do over this next year, and I firmly hope that this time next year when we're meeting at Rapid, you've got some updates for us.
Well, that definitely sounds great. I definitely appreciate this chance to talk to you about what we're doing.
Yes. Good luck.
All right, thanks.